We have Louis from PentesterLab. So I'm pretty sure he doesn't really need an introduction. I'm about 95% sure everyone knows who he is, but for those who don't, Louis is a security engineer based in Melbourne, Australia. He's the founder of PentesterLab, a learning platform for web penetration testing. So Louis, it is all yours, mate.
Unmute. Can people hear me? I guess, yeah, you don't get any.
Yes, we can hear you.
Oh, okay, perfect. So I was not sure about the background. I've put something pretty simple for now. Unless you like this one, guys. Got my favorite one so far. And this one. I'm going to try to check the question as well. Oh, the ComfyCon AU. So if you have a question, you can interrupt me at any time. Yeah, so let's get started. Share my screen. And can you see my slides now? Like, should be.
Yes,
like
we can.
Perfect.
And I can hear Andrea laughing in the background at your previous background as well.
Yeah. So my name is Louis, and I work for do this thing called PentesterLab, and I really enjoy bugs, and I'm kind of a CV connoisseur. And so that's my talk code that gets you pwned. You can see the regular expression in the title because we're going to cover a bit of that as well. If I get that thing moving. Yep. So my job is basically to find, collect, and study bugs and put them together to help people learn how to find, fix, and exploit bugs on their own. So I spend a lot of my time picking bugs, basically saying like, oh, this is interesting, this is pretty boring, this is the same kind of bugs of this one, and trying to find things that are really interesting and that will really help people get better at finding bugs and exploiting bugs. And so we're going to jump right in there. So I'm going to show you some example of vulnerable source code, and then you can spot the bug. So if you find the bug, you can put it in ComfyCon Slack, but I'm going to go through the code because it's pretty hard to like do it straight like that. So first here we have a little function in Golang that is used to upload file. So we can see on the second line that we're getting a file from the HTTP request. If there is no file, we generate an error and we return. If there is a file, we first create a defer to close the file in the future when we don't need it anymore. And then what we do is we're going to create a temporary file on the file system in /tmp and use the file name as the pattern used for the file creation, for naming the file. Then if there is no error, if there is an error, we return and print the error. Otherwise, we read the file we got from the request, and we manage error. So that's what is annoying with Golang, is that you spend your time reading like error management. Then we write the file we got from the request and put that on the file system in a temporary file. Then we close the temporary file. And if everything goes well, we write successfully uploaded the file. Not far, Silvio, not far, Silvio. Silvio is playing at home. He's pretty good at code review. He's teaching it. You should check out his training. He's pretty good as well. So the problem here is around temp file. So temp file takes two arguments. First, the directory where the file will be created. So most of the time you're going to use tmp or something like that. So that's where you want the file to be located when you create it. And the second one is a pattern. That pattern is used to say, we want the file to look something like that. We want the file to look something like Louis dot some random number dot txt, for example, or dot JPEG or something like that. And that looks pretty safe to use like that. But the problem is that what happens if you start using temp file and in the pattern, you put a directory traversal. And usually that file should still be created in /temp, right? And unfortunately, what Golang does is that it's going to traverse directory even if the pattern, even if the file should be created in /tmp, and because it's just going to concatenate /tmp with the result of the pattern. So if you have a directory traversal in the pattern, you're going to have a directory traversal and the file will be created somewhere else, which can be pretty surprising. and can probably lead to code exec if you can, for example, upload a GSP or PHP shell or something like that. And so that's something I reported to the Golang team. And it took me a while because I had to argue with them that it's probably not super common, but it's going to be something where people are going to shoot themselves in the foot. And so I reported it. I thought I had to argue a bit with the developers and to get people to help me argue with the developers. But at the end, it got fixed recently. And I think it should be in the recent version of Golang. If you do that, it shouldn't matter. You will still be in /temp. Yes, really good comment in the chat. You should check it out. So what happened in Python? The same exact thing. So in Python, you provide the directory and you provide a prefix. And if this prefix has a directory traversal in it, you're going to traverse directory and go here. Even if you want to create a file in /temp, you're going to end up in /root. And you have the temp file in /root. So which is kind of annoying and unexpected. Ruby does it better. So if you provide a temp file, if you use temp_file.new and you provide a pattern as the first argument, and then you say, I want this file in /temp, Ruby will do the right thing and remove the slash and create your file in /temp. So that's kind of something you need to be aware when you're doing code review, because it's not really obvious. Like you're creating a file in with temp file, it looks like something that shouldn't be dangerous, and it actually can be. Now, let's move to something else. So here we have a little application in Python, and we're using multiple libraries. And what we do is mostly we're using a URL to fetch a web page. And since we probably had like a pen test or a bug bounty before, we don't want to get owned. So we restrict the fetching to pentesterlab.com using HTTPS because we love things to be secure. Then so if the URL starts with pentesterlab.com, we fetch that URL and then we return the HTML in the page. So that's something people often do to download images or to create like a proxy to bypass the same origin policy. So yeah, so that looks pretty good. We're using starts with, so it should be safe. The problem that starts with is a really bad way to make sure something is actually part of a trusted list. So for example, if you start with http://trusted, you can see that http://trusted.pentesterlab.com starts with trusted. And same thing if you do @pentesterlab.com. The problem as well is that you don't do canonicalization before doing this starts with. So if you have another bug like a file upload or an open redirect or a header injection, you can use, okay, starts with trusted./jwks and then .. and go to another page on the website. And that can potentially create really bad behavior, and you can sometimes own people thanks to that, especially with the open redirect, because you can use that open redirect to go to a third party's website. And therefore, you're completely bypassing the usage of starts with. And that's pretty common in Golang, Python, Java, every application. And we're going to see some even more craziness. If you look at my background, this one is pretty good. We're coming very soonish. So, already there. So this is in C#. And this time, we're just going to make sure that the URL starts with http://. And as you know, like C#.NET now works on Linux and Windows, and the behavior will be the same on Linux and Windows for that bug. So you can think of, okay, we have a server-side request forgery. We can access any web server that starts with HTTPS. Or we can even try to do a port scanner by just changing the port as part of the URL. But that bug is actually even worse. If the URL starts with https:// and then you do like a directory traversal .. and you go, for example, on Linux to etc passwd, you're going to get the content of etc passwd. And the craziness is that the .NET framework mimic the bad behavior of Windows for directory traversal. On Windows, if you have this kind of path, you don't care, because even if https:// doesn't exist, it's still going to return the file you want, because Windows is going to ignore it. Linux, .NET on Linux will do exactly the same thing and return etc passwd even if https:// does not exist. So they took the bad thing from .NET on Windows and ported it to Linux. So yeah, directory traversal in .NET is pretty cool. And like here, you're using a web client and you do like, you don't know the URL, which is a string, but yeah, you don't know the URL and you end up with a file from the file system. So that's pretty crazy. I love that bug. Another one is again in Golang. Yeah, Silvio is adding that to his training. So here we have a simple URL that, a simple HTTP handler that will take a file name from the URL. It's going to open, it's going to clean the path because we want to make sure that everything bad is removed from the path. Then it's going to open that file. And then if there is an error, it's going to defer the closing of the file for later. And then it's going to, if there is an error, it's going to return a 404. Otherwise, it's going to copy the file handler from the file we just opened to W the response. Therefore, like the two file handler will be connected and it's going to copy everything and the file will be echoed back in the response. A few seconds for this one. So this one is as well pretty surprising. So let's look in depth at path.clean. So path.clean returns the shortest path named equivalent to the path by purely lexical processing. And that's the Golang documentation. And Golang documentation is really good because you can just run the code on the website. So that's what happened when you run it. So it's going to do, okay, if you do path.clean of a/c, you're going to get a/c. If you do a//c, you're going to get a/c. a/c/dot, you're going to get a/c. Then we arrive to the stuff that you think of when you're doing directory traversal, when you're one of the bad guy. Imagine you do /dot/ac, it's going to return /a/c. If you do /a/b /, it's going to return a/c. So it's cleaning pretty good, right? And as a developer, you see that and you're thinking, that's exactly what the security guy told me about. I need to remove .. Path.clean is removing .. for me. Thanks, Golang. You are an amazing language. Turns out what the documentation does not cover is that if the path doesn't start with a slash, and we have .. /ab, we are going to get the same exact result because it's trying to find the shortest path. And it's not going to remove all the .. bad things because it doesn't start with a slash. It's not canonicalization. It's not doing any canonicalization because you can't do it here. And as a developer, that's a really, really surprising behavior. And few people got owned by that. They think path.clean will clean up everything for them, but it doesn't. Now, another one, so that's pretty common when you're dealing with regex and hostname. So here we have an event listener. So basically when two HTML pages need to speak together, they're using events. And what the first thing you need to do when you do events like that, and that's everywhere in the Mozilla documentation, is you need to validate the origin of the event. So here what we're doing, we're following the documentation and we're validating that the message comes from pentesterlab.com. Since we want to make sure that we don't have this starts with issue, we're putting like a $sign at the end of the regular expression. So all the events will come from pentesterlab.com. And then we do something sensitive with the event, or otherwise we don't do anything. The problem with regex and .pentesterlab.com is that www.pentesterlab.com starts with match this regex, but www.pentesterlab.com still match it because the dot in the that looks good in the domain is actually a wildcard for regular expression. So it's going to match any characters. So, and that works as well for wz pentesterlab.com. So here's the problem is that as a developer, you need to remember that you need to escape dots in regular expression because they are wildcard. They're not a separator between a host name and domain and a TLD. They actually have meaning in the regular expression. Okay, so let's move to the next one, and we're going to go a bit harder. So that's maybe one Silvio won't find. So we have this little JavaScript node application. We have a list of domain that we allow. So example.org, gmail.com, google.com, and we have a fetch content function. And when we retrieve, when someone accesses our fetch function, we're gonna verify that the domain parameter is part of our allowed domains by using include. So basically, we're gonna search in the list of a domain to see the one, if the one provided is in the list. Pretty simple. Ooh, Nathan is right. And that looks pretty good, right? The problem is that here we have this request query domain dot to uppercase, and that's going to bite us because we can use a dotless I, which is often used in Turkish, and do two uppercase, and we get an actual I. So gmail.com with a dotless I, if we do two uppercase, will be gmail.com. So we have a bypass just by registering a domain. And that's something that happened to GitHub recently, where as part of the password reset, and that's a really good blog post that got me started looking at that in more depth. And as part of their password reset functionality, GitHub was matching like that, and then using the email provided instead of the email that matched. And that was used to bypass the password reset. And that's really, really interesting. And from the same blog post, you should read it, and someone linked it on the ComfyCon AU Slack channel. You can see that all the characters that actually behave weirdly when we go to uppercase or when we go to lowercase. And that's something that a lot of people get bitten by because no one knows about that, or very little developer, a very little number of developers know about that. And yeah. And the crazy part is that you're like, oh my God, this is some weird Ruby stuff. This is some weird JavaScript stuff. And that's what I thought at first. And that's actually not the case. It's actually part of the Unicode standard and part of the implementation guideline. So what happens is that if you have an I, if you in normal, which is like everyone except Turkish, you go from I to uppercase I, and you go from dotless I. So I don't know if you see my mouse, but here to the uppercase I here. And that's what is happening here. What is this even more surprising is that if your local on your system or on your server system are defined in Turkish, the behavior will be different. So lowercase I will become a uppercase I with a dot, uppercase I with a dot. And a lowercase dotless I will become an uppercase I still. So you have all this weird mapping that are actually some classic behavior. And most languages that don't follow this behavior do that because they don't have implemented that Unicode support well enough. So that's actually something that should work this way. So if you want to play Capture the Flag, I got two challenges that I'm going to keep running for the next, I don't know, 24 hours or something like that. So you can play online. Capture the flag.ag 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I bought an amazing domain and I'm pretty proud of it. So yeah, so check this out. You can scan the QR code on the video and I will leave them running. And that's exactly those two bugs. So we talked about two things, regular expression, and we talked about Unicode. What happened if we mix the two? Thanks, yeah, pretty good domain. So yeah, what happened? So if we do a regular expression to try to see if dotless I matches I, and in Python 3 8.1, it doesn't match. So, okay. Now let's add ignore case to the game, and we can see that dotless I will match I if we ignore the case. So let's say you have a regular expression to match your domain.org, and you're using ignore case, you're going to get beaten by that. So you shouldn't use ignore case when you're doing that. Thanks, Silvio. So same thing with I, same thing with the letter, the Latin long S, that looks like a weird F, and that is going to match S if you have ignore case. And same thing for the Kelvin sign, that is going to match K if you're using ignore case again. Yeah, so let's see other languages. In Ruby, the I, dotless I, will not match I, and will not match uppercase I ever, despite the fact that uppercase of dotless I is still I, as we saw before. But the Kelvin sign will match K. And so the 0 means that it matches, the nil match means that it doesn't match. And the Kelvin sign will match the K as well, the lowercase k. So that's, yeah, Kelvin symbol, sorry. Anyway, and the same thing for the Latin long S. It's going to match the S. So the I doesn't match, but the F or the S and the K do. So that's pretty weird behavior. But that's something that we have as well in Golang. So in Golang, the modifier, so ignore case is put at the start with bracket, question mark I bracket that you can see here. So it's not going to match the dotless I, and it's going to match, K is going to match the Kelvin sign, and S is going to, the Latin long S is going to match S. So yeah, pretty weird. Yeah. In C#, we got the behavior a different behavior as well. So the dotless I doesn't, dotless I doesn't match, dotless I doesn't match I. Kelvin sign matches K, but Latin long S doesn't match S. So again, like it's very much language dependent and as well version dependent. It's going to change between the version of the same language, depending on their support for Unicode and regular expression. What is interesting in C# is, I think, because Microsoft had to deal with so many issues with Unicode, they have all this way to do ends with and do string comparison with managing case. And you can see that they have invariant culture ignore case, ordinal ignore case. So that's probably the most expected behavior, which does this where INC matches INC, first one being without the dot. And depending, like you have all these different way of doing string matching. And you probably want to use the first one, invariant culture ignore case, just to avoid these kind of bugs. Now let's look at OpenJDK, and I did the same with the Oracle one. I did some testing with the Oracle one, and it works in the same way. So dotless I is equals to I is equals to dotless I if you do equals ignore case. Same for Kelvin sign and K, same for K and Kelvin sign. Same for Latin long S and S, and same for S and Latin long S. They all match. However, when you move to pattern matching, dotless I doesn't match I, Latin long S doesn't match S, and Kelvin sign doesn't match K. So that's, yeah, very, very weird behavior compared to what the equal ignore case gives you. And why should you bother about that? So let's say you have an application that have something with, okay, make sure the domain match something with an I, and we're going to use ignore case. Or make sure the domain match something with a S, and we're going to use ignore case. With that, you can register a domain, like instead of attacking, if you're attacking domain.org, you can register domain.org with a dotless I, and you can bypass this kind of protection. The same thing kind of work for the Kelvin sign, but the point is that to register, it's considered like an uppercase key, so it's characters, so it's really hard as far as I can tell to get a domain register with that, or even impossible. The same thing happen if you do an email address, or you're going to validate the email address, but since some people will put characters as uppercase into the domain or as part of the email address, you're going to match an ignore case, and you're going to run into the same problem. The same as well can be the case with cross-origin resource sharing, in that if you match the host name using case insensitive, you can run into the same thing. But it's most likely that your browser will not send the right value because it's going to encode the domain as Unicode. So unless you have an equipment that does the translation, the decoding back from Unicode to like Unicode string, it's unlikely that it works for cores, but still interesting to look at. And that's it. So basically, to conclude, I don't know, that's really hard. Like, I guess computers are really hard and you have a lot of details to look into. And I think these bugs really highlight how like some source code can look clean and may be dangerous, even if it looks perfect. Like the example with Golang and path.clean looks pretty nice and pretty safe. The example with Unicode looks pretty good, but you need to remember that any modification of a string can have impact. Don't make any assumption. And yeah. And that's it for me. So thanks you for your time. And if you have any question, make sure you stay home and stay safe. And yeah, thanks. And if you have any question, I can see on ComfyCon question, or if Ian wants to jump in.
Yeah, so thank you very much, Louis. I will be 100% honest. I don't understand half of that anymore because I don't do software engineering anymore. It's just a black art to me. But I know there's been a lot of chat about the guys trying to guess what the bugs were. And of course, we had certain people guessing them much quicker than others. But yes, no, that was awesome. Thank you very much.
Thank you.